We're going to be solving systems of equations using substitution. So I know there are multiple ways to do this, but today we are going to focus on substitution. With substitution, you want to get one of the letters of one of the equations by itself. So I'm going to pick where we have positives right here. Let's subtract y on both sides. And that will give us x equals 4 minus y. Then you go to the other equation. This x is a quarterback who tripped in a hole on the field and broke his leg in 3 places, so obviously cannot continue playing the game. So x is going to be removed from the game, and 4 minus y is going to go in his place. So 4 minus y goes in place of the x. And then we continue the equation, minus y equals 2. If there happens to be a number in front of the parentheses, you would need to distribute. There is not in this case. And minus y means a negative 1y. What is negative 1y and negative 1y? Negative 2y. So we have 4 minus 2y equals 2. Subtract 4 on both sides. And then divide by negative 2. Y equals 1. Do you remember doing this in Algebra 2 and in Geometry and in Algebra 1? Yeah. Once you know that y is 1, you've got some options. You can plug that 1 into the y in the first equation, you can plug it into the y in the second equation, or you can plug it into the y in this new equation that we created. I like to do the least amount of work possible. So x equals 4 minus y. We know that y is 1. 4 minus 1 is 3. Technically, you should write your answer as an ordered pair, x first, y second. The solution for this system is the ordered pair 3, 1. This second example is my favorite type. Basically, y equals stuff. Y also equals other stuff. So stuff is going to equal other stuff. Go back. Y equals this. Y also equals that. The y's are going to be the same. So if these two y's are the same, then these two boxes have to be the same. Put 5x plus 12 equal to negative x plus 6. Is that an equation that you know how to solve? Absolutely. Add x to both sides to get 6x plus 12 equals 6. Subtract 12 on both sides. Divide both sides by 6. X equals negative 1. Now what? My class just wants to stare at me today. They don't want to. We need to substitute the negative 1 into an x in one of the original equations. You can pick whichever one you want. I don't like the idea of doing negative 1. That just seems confusing to me. So I'm going to use y equals 5x plus 12, but you could use negative x plus 6 if you wanted to. 5 times negative 1, don't know what I'm writing. 5 times -1 is -5. -5 plus 12 is 7. So y equals 7. The ordered pair, -1, 7, is our solution for that system. When you have examples that look like this, I want you to think about strategic laziness. Would it make sense to try to get y by itself in this example? We'd have to subtract x on both sides, then we'd have to divide by -3. You really don't want to have to divide anything. So in this example, you should get the x by itself by adding 3y to both sides. So we will have x equals 3y plus 2. In the next equation, we are going to replace x. Because we have x equals, we are going to replace the x. Parentheses are your friend. You're taking the x out, and you are putting 3y plus 2 in its place. And then continue with plus 6y equals 2. What do we need to do next? That's right, we need to distribute. Good job. Do you hear the sarcasm? No? Okay, I'll try harder. Sorry if you're listening online. I'm really not a sarcastic person, like, ever. It's funny. -6y and +6y. What happens with -6y and +6y?
They cancel out.
Cancel out. So we have -4 equals 2. Does -4 actually equal 2? No, this is a false statement. When your variables eliminate and you have a false statement, that means that there are no solutions. All right. Basically, this means that there are two lines that have the same slope. They're parallel. They are never going to meet. So there are no XY combinations that would work for both of them. Now let's try this next one. And because in a lot of our examples we've gotten x by itself, some people try to think, oh, well, we have to get x by itself in the first equation. No, you don't. Which letter looks the easiest to get by itself? That y. You want to look for a naked letter. Look for a letter that doesn't have a coefficient. So we want to subtract 3x on both sides. And then we are going to put that in place of y in the other equation. So 9x plus, go back, 3 parentheses, -3x plus 5 equals 15. Distribute. And once again, we have 9x minus 9x. So we end up with 15 equals 15. Does 15 equal 15?
Yes.
This is a true statement. When you get a true statement, that means there are infinitely many solutions. If you just want to write many solutions, that's fine. Some of you write IMS for infinitely many solutions. As long as you know what that abbreviation means, I'm okay with it. This means that there are two lines that are right on top of each other. So every single point on one line is also going to be a solution to the other line. All right, you ready for word problems? Word problems are fun. We love word problems. I can make a sign if I have to. A farmer wants to mix two types of hay. The first type sells for $125 per ton, and the second type sells for $75 per ton. The farmer wants a total of 100 tons of hay at a cost of $90 per ton. How many tons of each type of hay should be used in the mixture? There's basically two types of information in here. There's information about the amount of hay, there's also information about the cost of the hay. Let's first talk about the amount of the hay. How many tons of the first type are we going to get? Do we know? So X, we're going to get X tons of the first type of hay. How many tons are we going to get of the second type? We don't know, so we'll call that Y. We're going to get Y tons of the second type of hay. If I add those two amounts together, how much hay are we going to get total? 100 tons. So the amount of the first type, which we don't know, the amount of the second type, which we also don't know, equals the total amount. This is the easy equation. Now let's look at the also easy but slightly a little bit different equation. Do you remember in math that the word per means multiply? So $125 times the amount of hay that we get, that's going to be how much we spend on the first type. The second type is $75 per ton, so 75 times the number of tons we buy, that's how much we're going to spend on the second type. Add those together, and it needs to equal this number, which needs to be the total cost. The problem is $90 is not the total cost. They're saying it's going to be $90 per ton. How many tons are we getting total? 100. $90 times 100 tons is going to give us a total of $9,000. So this box is the price per ton times the total number of tons. Okay, writing the equation, that's the difficult part, right? You have a word problem, writing the equation is the most difficult. Once you have the equations written, is solving easy or difficult? Easy. Pick X or Y, get one of them by itself, substitute it into the other equation, solve for one of the types, and then solve for the other type. Do we need to actually finish that example, or do you feel like you're good? We're good? Okay. If you're watching on the video, I am going to work out this problem and show the answers. So if you want to pause it and work this out on your own and then play it, you'll see the answer, or yeah, whatever. Just hang on a second.